the contour integration, and you know the principles. So today we will practice more questions on contour integration. Okay, let us practice more questions on that. So uh, I am going to take the next question, and that is uh, contour integration C and cos of z by z dz, and C is given as mod of z is equal to 1 and counter clockwise. Okay, this is the question. Okay, so some contour integration is given, and this time the definition of C is also given. Like I told you, this will be given in every question, and the first step is to know the function fz, and that function fz is given by uh, cos of z upon z. Okay, that function is given by cos of z upon z, and uh, the contour that is given is actually a circle with center at origin and radius 1. Can you see this? Mod of z is equal to 1. So what is the general definition of circle? It is mod of z minus z naught is equal to r. This is the equation of circle where z naught is the center and r is the radius. So this is 1, this will be minus 1, this will be iota, this will be minus iota. On the argand plane, we will draw it like this. Okay. Now we have to see what is the value of pole. So the value of pole is given as z is equal to 0. You can see the denominator. It is the case of a simple pole, and let us calculate the residue. So you can calculate it using any method. I am this time using Laurent series, that is 1 minus z square over 2 factorial plus z to the power 4 over 4 factorial upon z. So that means b1 is equal to 1. Okay, the value of b1 is equal to 1 in this Laurent series, and you can see that this pole z is equal to 0 lies inside our contour. So if it lies inside our contour, we will calculate the residue, and the answer will be, because it is counterclockwise, so answer will be 2 pi I into 1. Okay, that is the answer. Is this clear? So let us be little quick today so that we can do lot of problems. So is this clear to everyone?
Yes,
Sir.
So every concept is used. Even in this simple question, you have used each and every concept. That is a thing to be noticed. Okay, so let us take the another one. Okay, so let me somebody was asking yesterday about the point lying on the axis, if you remember. So let me take a question to clear that concept. I told you that I will teach that concept using a problem. So I am taking that problem, and that is like this: integral C 1 upon z minus z0 dz, and the contour C is like this. Suppose C is like this, and in case A, it lies well inside. In case B, it lies on the contour, and in case C, it will clear all your concepts. It lies outside the contour. Okay, so what is the answer for A? This lies inside, and this is the B1 only. So what is B1 in this case? 1, and the value of integration I is equal to 2 pi I. Please see this carefully. It is on the contour, so the value of I will be equal to pi I. I told you the contribution will be half, and it is outside, so the value will be 0. Value of integration will be 0. So I hope this problem clears your that doubt. Okay, in which you had a problem that what happens when your pole is on the contour, or it is inside or outside. So all three concepts are clear. Yes.
Yes, sir.
So this also I'm going to erase if you have noted it down. So let me take the next question, and that is like this. Integral C cos of z over z minus pi I square dz, and this is C, and pi I is like this. I mean the contour is inside, the pole is inside the contour. So please see this one. Uh, Z is equal to pi I is a second order pole. Huh? And it lies inside the contour. Inside the contour. So no problem up to this. So write the Fz. Fz is cos of z over z minus pi I square. So it is a second order pole, so you can use formula for nth order pole. Yes, you can use formula for nth order pole. And अभी अभी मेरे दिमाग में आया कि मैं एक काम ये भी कर सकता हूँ कि cos की सीरीज को ओपन कर लूं ना, then also I can get, the only thing is I will have to open it so that z minus pi I should appear. So uh, the homework is do it by using nth order pole, I mean second order pole. And what I am going to do is z minus pi I plus pi I. I can do this. So this will become cos A, cos B minus sin A, sin B over z minus pi I square. So what is the formula for this? 1 minus z minus pi I square by 2 factorial plus z minus pi I to the power 4 by 4 factorial into pi I cos of pi I. Yes? And we will not get any coefficient of 1 upon z minus pi I from here, but we will get it from here. Minus, if you see, the first term itself will be z minus pi I. Yes? And second one will be cube, like this, and into, over z minus pi I square, z minus pi I square. So if I just want to know the b1 will come by when this is divided by this. So it will be sine pi I is also multiplied. So into sine pi I is also there in the numerator. So when this will be multiplied, it will be 1 upon z minus pi I, and what is the coefficient? b1. It will be minus sine pi I. Please see this. Are you understanding that? So what is the answer for this integration? It will be 2 pi I into minus sine pi I, which is 2 pi I into minus I sine hyperbolic pi. If you remember the cyclic thing, and this iota minus will be cancelled, so your answer will be 2 pi sine hyperbolic pi. This is the answer. Please check this. You like this writing Laurent series? So in a way we did two questions. We also wrote Laurent series, and we also did this calculation of integration. For
So,
for simplicity, you can also put z minus pi I equal to t. So that whole thing will become very simple. Yes?
So the 3 factorial,
3 factorial?
B1 does not
Efficient
include.
diagrams.
What is b1?
So B1 is a coefficient, right? So the 3 factorial, where does it go?
No, what is b1? The question is what is b1?
B1 is the coefficient of z minus pi I.
1
1
upon.
by z minus.
So 1 upon z minus pi I will come from this, na?
Oh, yeah. Sorry, sir.
Yeah, next one. Next, who was asking?
Sir,
Quickly पूछो, देखो time मत
sir,
waste. Don't waste
sir,
time.
initially, how can we say the pole is second order? Because if we're expanding cos, then it may.
हाँ, you just from seeing from here, na?
Okay, sir. So in this case, we can directly say initially from its second order.
Because it is not there, na? It is not here. Here no z minus pi I is there.
Oh,
So that's why I said. And see, it appears also. What is the pole? See the first term, 1 upon z minus pi I square. That means it is the second order pole.
yesterday. Okay, sir.
If it was z minus pi I here also, then story would be different. Okay. So can I erase this? Everybody got this? Understood? Homework is using the formula for nth order pole. Okay. Answer will be same.
Yes, sir. Yes,
So
sir.
I am erasing it. So coming to next question. Okay. This is a question. So you can see that z is equal to minus iota is a pole. Okay, and what type of pole is that? Z is equal. So that means we will have to apply the formula for nth order pole. Yes, we'll have to apply the formula for nth order pole. So let us do that. Fz is z to the power 4 minus 3z square plus 6 over z plus iota cube, and residue at z is equal to minus is given by 1 upon 3 minus 1 factorial d3 minus 1 by dz3 minus 1 z plus iota cube into z to the power 4 minus 3z square plus 6 over z plus iota cube. This is the way na to solve.
Yes, sir.
Yes.
So this will become 1 by 2, and then this will be cancelled, and 2 times derivative of this. So 1 time derivative will be 4z cube minus 6z, and 1 time again will be 12z square minus 6. So it will be limit z tending towards minus iota 1 by 2 and 12z square minus 6. So what will be the answer? It will be 6z square minus 3, and z is equal to minus iota, put कर दो, तो 6 minus iota square minus 3, so minus 9.
Yes, sir.
So what will be the answer? 2 pi I into minus 9 means minus 18 pi I is the answer. Check this.
Yes, sir. Same.
Same.
एक्सक्यूज मी सर
Hmm.
सर यहाँ पे z प्लस आयटा पावर क्यू के लिए हमने जैसे लिखा कि z इजकल टू माइनस आयटा ऑफ थर्ड ऑर्डर पोल,
Hmm.
तो नोमरेटर में कोई भी टर्म लिखा होता है उसका कोई रोल नहीं रहेगा
नहीं, उसका रोल है ना, लेकिन देखो तुम कहीं पे भी z प्लस आयोटा जैसी चीज तो लिखी नहीं हुई है ना, तो नथिंग इज
अच्छा।
गोइंग टू कैंसल.
ओके सर.
और अगर ये होता नहीं तो ये वैल्यू भी इनफाइनाइट आ जाती, ये भी समझ लो. बिकॉज आप देखो ना, ये दोनों आपने काट दिया.
जी सर.
अब अगर सपोज ये फोर्थ ऑर्डर पोल होता तो आप सिर्फ अगर 3 से मल्टीप्लाई करते यहाँ, तो एक यहाँ बचा रह जाता.
जी सर.
और फिर वो इनफाइनाइट हो जाती वैल्यू ना.
ओके.
So that is like a test also. Okay, so let me solve another one, and that is integral sine z over 2z minus pi dz, and mod of z is equal to 2. Okay, yes, this is the question that we have to solve. So now please see, in the questions where this z gets a coefficient without thinking anything, just don't think anything. Before thinking, take this half common. Okay, otherwise you will commit a mistake. So that's why take this half common. So now what is fz? It is half sine of z over z minus pi by 2. Okay, and if you like, you can again use my trick For Laurent series, your this will become, let us take z minus pi by 2 is equal to t, if you like this. So it will become half sine t plus pi by 2 over t. Is that okay? And this will become half, what is sine 90 plus theta, cos theta? So it will become cos of t, and this will become half over t, 1 minus t square by 2 factorial plus dash dash dash. If you remember, it will become this. And what will be b1? 1 by 4. Is that okay? And we have to also see that this lies, ये मैंने पहले नहीं देखा, मुझे पहले ही देखना चाहिए था. So this is the circle, this is 2, this is 0. And this is pi by 2. The pole is at z is equal to pi by 2. So pi by 2 lies inside. This is pi by 2. Okay? So what is the answer of this? 2 pi I into minus 1 by 4. So it is minus pi I by 4. Please check this.
सर b1
pi 2
by 2 नहीं होगा
Sorry?
minus pi I by 2.
1 by
Sir,
2 नहीं होगा
b1 equal to 1 by 2.
अरे मैंने कट कर दिया, फिर से लिख दिया.
Sir, b1 की वैल्यू 1 by 2.
Sir, b1
1 by 2
b1 की वैल्यू, सॉरी ये कैसे लिख रहा हूँ यार. b1 की वैल्यू 1 by 2 and this will become 1 by 2, so it will become pi I. Sorry. Okay. See this, if there is any doubt. Moving to next question. This is integral c dz z square e to the power z, and the contour is c is given like this. This is our axis actually, and this is the contour, and this axis is suppose this is 0, this is minus 1 comma 0, and this is 1 comma 0. This is the axis, and this is y axis, this is 0 comma 1. Okay, now the solid line is the contour and the dotted line is the axis, and we have to find out this integration. So how to do this? So you can see this time the contour is not a closed contour. Yes, contour is not a closed contour. We have an open contour, but we know formula only for closed contour. So we have to somehow start by this. Let me start by this. Integral c fz dz is equal to 2 pi I sum of residue. This is always true. And let me put it as c dash because c notation already used ho gaya hai. So let me close this contour like this, and then I have written this formula. Any objection? And then I will write it like this: integral c fz dz, the solid line, plus integral minus 1 to 1, because you are traveling on the x-axis, so y is 0. So I can write just fx dx is equal to 0, because this function has no pole, it is analytic function. So right hand side is 0 because function is analytic. Function is analytic, and this I have written z is equal to x because you are moving on the real axis. On the real axis, y is equal to 0. Fine. So you wanted this value, your question was this. So integral c fz dz was your question, that is only equal to -1 to 1 fx dx. That means dx x square e to the power x. And this will be equal to minus first function integration of second minus derivative of first function integration of second plus derivative of this function integration of second minus 1 to 1. So let us substitute the values, upper limit and lower limit. So upper limit will be e minus 2e plus 2e. This is upper limit, minus lower limit is e to the power minus 1 plus 2e to the power minus 1 plus 2e to the power minus 1. This is the lower limit. This will be cancelled. So the value will become minus e minus 5 by e. So it will be 5 by e minus e. Please see this. This is a very nice question. Actually, one of the previous year's question. This integration is UV integration. So I think you understand. Integration UV. First function integration of second minus derivative of first function integration of this plus u double dash v3 minus dash 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 जब तक कि u खत्म ना हो जाए. Any doubt you can ask, otherwise I will move to next question.
No, sir.
So you have seen that it was so fundamental about the closed contour that this question checks your concept of closed contour, that you remember the definition correct or not. It checks closed contour. Yes?
Sir, but question it was not given like close contour.
No, not given, na. So that's why they have not asked the integral for closed contour. They have asked the integral for open contour. But we have made another contour which is a closed contour, and our open contour is part of that. So you can see that if I go from here to here and then from here to here, it will be a closed contour. So I have written C dash like that, and then that is sum of these two, na? One is this C and another one is this straight line. So this was for a straight line, which is z is equal to x. Moving on the real axis, because this axis is real axis. Got it?
Yes, sir.
Lower part everybody has written, na? Ye niche wala?
Yes, sir.
Okay. So let me erase this also, and we will. And this UV formula, please remember that formula. If you don't remember it, we will be using that very frequently. And integration UV is equal to UV1 minus U dash V2 plus U double dash V3 minus like that. And what is meaning of V2? V2 is actually integration of V1. What is V3? It is integration of V2, like that. And derivatives you understand. Please note down this. This makes your calculation very very quick. और ये पहला दूसरा मत करने लगना, नहीं तो उसमें ब्रैकेट खोल 3 बार खोलोगे वो गलत हो जाएगा. Okay, so let us take next question. Integration C z cube dz over z square minus 5z plus 6, and C is given a contour which is like this: 2z minus 5 is equal to 0. The question is this. Okay, so now let me write our contour first. Mod of z is 2.5. This is our contour, so it will look like this: 2.5 here, and this is 0, centered at origin. And let me write this: z square minus 5z plus 6 is equal to 0. What are the roots? So minus b plus
2 and
minus
3.
under root b square minus 4ac over 2a. So it will be 5 plus minus 1 by 2. Okay, so it is 2.5 plus minus 0.5. So it is 3 and 2. Okay, you could have written it by splitting the middle term also. So it will just become z minus 3 and z minus 2. Okay, so what will be my function fz? My function fz will be z cube over z minus 3 z minus 2. So you can see 2 will lie here and 3 will lie here. So only 2 will be considered because it is inside. So it is a simple pole. So residue for z is equal to 2 will be given by limit z tending towards 2 z minus 2 into z cube over z minus 3 z minus 2. It will be cancelled, and if you write z is equal to 2, it will be minus 8. देखना कोई calculation में mistake ना हो. So answer will be 2 pi I into minus 8, that means minus 16 pi I. Check this. Okay,
Yes, sir. Same, sir.
all others feel free to ask if there is any doubt.
No, sir.
No, sir. It's clear now.
So let me take another one, and this is like contour C dz over sine square z mod of z is equal to half. Okay, now the for poles or singularities you will put sine square z is equal to 0. Yes, and that answer will be z is equal to n pi. Correct? For any of the values of n pi, your denominator will become 0, but let me check this also. This is 0.5 minus 0.5, 0.5 iota minus 0.5 iota. Okay, so let us see the poles. Sine of n pi is 0, no? So if you calculate this sine square z is equal to 0, that means sine z is 0. That means z is equal to n pi. Okay.
Here modulus of 2 is 1 by 2. Okay, sir. Given us.
Sorry.
So mod of z equal to 1 by 2.
अरे यार ये कंटूर है भाई,
Okay.
अभी उसी में फंसे हुए हो. In every question we are writing some contour, na? Okay. So let us see the poles. So you see z is equal to 0 is a pole, huh? And the first pole you will take pi, that will go somewhere here, or minus pi, it will go somewhere here. That means no other pole will lie inside. Can you see that? So out of this 0, pi, minus pi, only this 0 is acceptable. Can you see that? Because that only lies inside the contour, given contour. It is given. So where we have to find out residue? Only about z is equal to 0. So let us do that. So fz is equal to 1 upon sine square z. We have to find the residue. So what I am going to do is, I will write it like this: z minus z cube by 3 factorial plus z to the power 5 by 5 factorial dash 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 square. Okay. And then I will take z common, so it will become z square, and it will go up, it will become 1 minus z square by 3 factorial plus z to the power 5 by 5 sorry, one z is gone, na? Z is common, na? So z to the power 4, correct? Minus 2. Please see this carefully. एक बार ध्यान से देख लो, कोई डाउट है तो बताना. So when you will open it, this has no power of z. Can you see that? Because you know this will become some, you will take this common and this will become minus here and dash 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 like this. So it will become some 1 plus nx plus nn minus 1 by 2 factorial. But you need z here to get b1, because b1 is 1 by z, coefficient of 1 by z. So that is absent, so b1 is 0. So that's why the value of integration is also 0. Please check this. देखो बात समझ आती है सबको?
Yes.
Any doubt anybody wants to ask? Now, next question is, half part of that question we have done already when I was doing the residue. So that is 1 upon 2 pi I contour integration C e to the power 4z minus 1 over cos hyperbolic z minus 2 sine hyperbolic z dz, and mod of z is equal to 1 is the, what is this? Venkat, you always ask.
Yes, sir.
This is from where this is coming?
Question.
Given. Okay.
Yes.
So this question, I hope you remember it. Don't forget this 1 upon pi I. It is given in the question here. Okay. So you will write the answer as 2 pi I, and you already calculated the residue if you remember. Minus 8. किसी को याद है?
Minus 8 by root 3.
8 by root.
Root 3.
So what is the answer? Yes? But you remember the struggle na, to calculate the residue in this question? Remember that? So I have used that directly in this question, but I hope you would have practiced it also. So let me take the next one. So this simple complex integration, all of this complex integration we have done today, and then we will switch to how we can use this complex thing for real integration. That I will do in next class. So z plus 1 over z plus iota z minus iota, and mod of z minus iota is 1.4. This is given. This is given. So let us do this question. What are the poles? Iota and minus iota, and let us draw the contour. Z is equal to iota is the center and 1.4 is the radius. So somewhere here it will come. This is the circle. Okay, and your iota will lie here and minus iota will lie here. Can you see that? Because the radius was 1.4, so that's why this is 1 unit and this is say 0.4 unit. So if you mark this on the line, it will be minus 0.4 iota. Can you see that? So only one pole is inside. So let me write the integration. It will be 2 pi I into residue. So z minus iota will be cancelled. So it will become log of iota plus 1, because z is equal to iota, we have to put over 2 iota. So this will be cancelled. So it will become pi ln of iota plus 1. I mean 1 plus iota. So that will be written as pi and ln of under root 2 into e to the power I pi by 4, if you remember. 1 plus iota plus 1 can be written like this. You remember this? So this will become pi ln of root 2 plus I pi by 4. This will be the answer. Please check this. If there is any doubt, feel free to ask. I have written 1 plus iota is equal to under root 2 e to the power I pi by 4. Yes, tell me.
Sir, z is equal to minus 1 is also the pole, na? ln will be not defined on 0.
So that also goes outside. Ln is equal to minus 1. Okay. So for that, actually, you will have to check like this. This distance is what? 1.4 and this distance is 1. So what is this distance? Tell me. So that will be 1.4 square 1.4 square minus 1 under root. ये बताना जरा कोई.
So 0.97.
0.97. So it will be minus 0.97. So it is just outside. Okay.
Yes, sir.
That was good question. And answered very well, no?
But sir, if we only had to calculate the residue, then how would have been proceeded?
Like we have done. Z is equal to minus 1 is actually not a simple pole. That is known as branch point. Okay, so there is entirely a different method to handle that, but the method of calculation of residue will be exactly same.
Okay, sir. Thank
That
you.
means suppose you want at z is equal to -1, so that means whatever is the function, coefficient of 1 upon z plus 1 will be the residue. Okay, the definition of residue will not change. Tell me if there is any doubt in this. अभी forget about this log thing. अभी ये बाहर चला गया ना, अभी इसको ऐसे ही रहने दो, क्योंकि वो अलग से सबसे लास्ट चैप्टर वही रहेगा, ब्रांच पॉइंट, हाउ टू डील विद दिस, विद दैट. Any doubt in this? Otherwise I am going to stop for today. If there is any doubt, you can ask. So from next class, we will solve real integrations, because these are complex integrations. अभी तक असली यूज नहीं पता चल पाया है. असली यूज ये है कि the real integrations that you are solving can be solved. I gave you few glimpses using Euler's equation, na? Like sine cos or exponential sine and cos. But there are so many integrations which are very difficult otherwise, and they can be handled using contour integration. So that will be our next task. So you just revise all the questions we have done, see all the minute steps, draw these contours by yourself, seeing the center and the radius. Do it by yourself. See the pole lies inside or outside, mark them. पहले थोड़ा आराम आराम से करो, प्रैक्टिस करते समय. ठीक है? Thank you.
Thank you.
Thank you, sir.
Thank you. Thank you so much.